The William W. Hay Railroad Seminar Series is sponsored by the Rail Transportation and Engineering Center here at the University of Illinois at Urbana-Champaign. On behalf of all of us, we thank AAR, BNSF, CN, Hanson Professional Services, and Union Pacific for their ongoing support of Rail Tech and this seminar. It's greatly appreciated by us here on campus as well as those participating via the internet. I want to welcome the more than 200 people who have registered for this seminar. They hail from 9 nations in 3 different continents around the world. There are a lot of people paying attention to you, Tom. The list of attendees includes freight and passenger railroads, transit organizations, federal and state agencies, engineering firms, universities, research organizations, technology developers, and suppliers, and others. And we're very pleased that you could all join us today. Those of you who wish to receive PDHs for your participation, please see the instructions at hayseminar@illinois.edu and provide your information as described in the email announcement for this seminar. High-speed rail has been developed in more than 24 nations around the world. Most of these projects have been government funded and most are dedicated passenger lines. Brightline is unique because it is neither. It's a private company expanding an existing freight railroad to accommodate higher speed operation, with some portions to operate as fast as 125 miles per hour. Brightline opened its initial route between Miami and West Palm Beach, Florida in 2018 and is currently constructing an extension to Orlando that will open in 2023. Future plans include a connection to Tampa, and a second system, Brightline West, will connect Southern California with Las Vegas. This presentation is going to focus on the design and construction of the Orlando extension, including the innovative design work, critical construction activities, and close coordination with freight rail and community partners that have made the project possible. Our speaker today is Tom Roadcap. He's well known to us. He's an alumnus of our program, and he's currently a project engineer at Brightline Trains and is involved in design, review, construction planning, construction management, and maintenance of way planning at both Brightline Florida and Brightline West. As I mentioned, he holds BS and MS degrees in civil engineering from the University of Illinois, and he conducted research here with Rail Tech. He also led the ARIMA student chapter and worked summers at the Union Pacific Railroad and Canadian National Railroad. Prior to joining Brightline, Tom worked on railroad track research and testing in Munich, Germany as part of a Fulbright research project. Please join me in welcoming Tom, who will present today's Hay seminar entitled Brightline, Bringing Private High-Speed Passenger Rail to the United States.
Thank you. Awesome. Well, thank you, Chris. Can you all hear me all right? Is that good? Good in the back? Okay, wonderful. Yeah, thank you, Chris. It's really an honor and a pleasure to be here with you all today to share a lot of the exciting things that we're doing at Brightline. So I'll dive right in. If you're not familiar with Brightline, we're a private passenger rail company, an American company, and our mission is to challenge the transportation status quo in the United States and to reimagine what it means to travel by train. And we're doing that using kind of our newer model for developing passenger rail in the United States. We're currently developing 2 major projects. One is Brightline Florida that you can see here on the right. That's what I'll spend most of my time on today. And this is a higher speed passenger rail project connecting South Florida to Central Florida. And we're also developing a second project between Southern California and Las Vegas that we call Brightline West that will start construction soon. And in general, our goal is to connect city pairs that are too far to drive and too short to fly. And if that sounds familiar, we didn't think it up. So I'm sure, you know, my wife and I, we've had T.C. Gow on our minds a lot lately with his passing. I'm sure many of you had as well. He was a huge mentor to us. And some of the things that he talked about frequently are also core principles of what we're doing at Brightline. One of those is connecting city pairs that are, again, too far to drive and too short to fly. This was a slide that TC showed in all of his courses from Japan, showing how motorway vehicles or autos are really best suited to those shorter distance trips, 200 to 300 kilometers and under. Air transportation is best suited to those longer distance trips, 700, 800 kilometers and more. And that gap in the middle, you know, the best way to fill it, we believe, and TC often said, is high-speed rail, and that's exactly what we're trying to do. Something TC also talked about quite a bit that's also a core principle of Brightline is the ways that private enterprise can be a part of or work together with other government bodies to build high-speed rail. So of course, the top left there is Taiwan High-Speed Rail that TC had a huge part in building. But some of these other projects also have major private components. This is the InfraSpeed line that connects the Netherlands and Belgium, which was built and operated by a private consortium. Same deal here in the bottom on the right. That's the Tours Bordeaux high-speed line in France that was built and is operated by a private company that charges tolls or track access fees to SNCF and other private high-speed rail operators that want to operate on it. And then in the bottom left there is Italo, which is a private company that operates their trains on national infrastructure in Italy. Another theme from TC's courses was transit-oriented development and how the arrival of high-speed rail in a community can really revolutionize a downtown area or develop a new area, and that's something we've taken to heart at Brightline. On the left, that's our West Palm Beach station. The station's in the foreground, and then in the background is a high-rise apartment building that we built on land adjacent to the station that we own. So we can be not only your transportation provider, but also your landlord if you want. On the right is our Miami Central station, and that's one of 3 towers that's an overbuild over that station, an office tower that I'll talk more about. Another key piece of the Brightline model is using existing transportation corridors. So this is a Google Earth screenshot that I took of the Central Valley in California, where California High-Speed Rail is building their project. They're working with quite a different set of constraints and goals than we are, and they have a really tight tolerance on the travel time they can achieve between San Francisco and Los Angeles on their project. As a result of that, they need to keep their train speeds at maximum speed for many places, and therefore they can't compromise on having, for example, tighter curves or lower speeds. And they, as a result, come to a design where you have this gradual curve that you can see just in this photo alone, maybe crosses 10 or 15 different parcels. And you can imagine that land acquisition is both expensive and time consuming. Even if you can use eminent domain, which they can, it's not going to be quick and it's not going to be cheap. We're a private company, we can't afford to finance land acquisition like that, and so our model instead is to follow existing transportation corridors, which is both less expensive, faster, and also tends to have lower environmental impacts. On the left there you can see a photo, an aerial photo of our new track being built between Cocoa and Orlando for the Florida project. This is track that we built on an easement that we have with the Central Florida Expressway Authority and with FDOT to use their existing right-of-way to build our track. That way, we're not purchasing or negotiating for easements over thousands of individual parcels. We have one entity that we have to work with, and fortunately, FDOT and CFX have both been great partners to work with who share our vision for a more multimodal transportation network in Florida. On the right is the Interstate 15 corridor. This is the interstate that connects Las Vegas and Southern California, and it's also where we intend to build our Brightline West project, again following an existing transportation corridor so that we only have one major property owner to work with. And in fact, we just announced last week that the 1 mile of our project that's not in the I-15 corridor we were able to acquire. So we're now 100% done with land acquisition for Brightline West, which is a huge step. We're the only high-speed rail project in the country that's completely done with land acquisition, and that's one of the things that makes us be able to truly say we are construction ready, shovel ready. So let's dive into Brightline Florida a little bit, and we'll start first with our phase 1, which is the operation that we're currently running. As Chris said, we started in 2018 between Miami and West Palm Beach. This is a 67-mile route. It's got 178 grade crossings, and we are operating today with 34 to 36 trains a day, hourly departures in each direction between Miami, Fort Lauderdale, and West Palm Beach. To build this project, we essentially took the existing FEC freight rail corridor, which is Florida East Coast Railway is our freight partner. It was primarily a single track corridor with passing sidings, so we double tracked it, built the 3 stations as well as our maintenance facilities. And here's a picture of one of our trains leaving the Miami Central station. Here's a photo of our trains. So they're all brand new train sets manufactured for us by Siemens in Sacramento, California. They're Buy America compliant. Because our project is privately funded, we're not required to meet Buy America guidelines, but we've chosen to where we can anyway, and our project is Buy America compliant. These locomotives are the Siemens Charger locomotives, and then the coaches are the venture coaches. We were the launch customer for those coaches. We typically run them with 2 locomotives, 1 on each end and 4 cars in the middle, but some trains we may expand soon because of demand. I'll talk about that more in a minute. Here's what it looks like in the cab of the trains. So because we operate on a shared corridor with FEC, we use their signaling and train control system, which is an ATC system, automatic train control. That's a legacy system they've had on the corridor for a while. The lower of the 2 screens in the top right is the ATC module, and then in the middle of the driver's console is the, I can point to it, this is the PTC screen where all the PTC information is displayed to the driver. And then right next to that, there's also in-cab signaling. So this displays the cab signal aspects while the train is operating. Like I said, we're typically operating our trains with 4 coaches. One is the premium coach. This has a 2x1 seating configuration. The ticket in premium includes free snacks and drinks for the guests, and then there's premium lounges in each station that also have buffet food and plenty of drinks. Smart Class is our offering that has 2x2 seats. We have 3 coaches with Smart typically on our trains, and there the snacks and drinks are for purchase. But no matter which class you're riding in, riding on Brightline is a one-of-a-kind guest experience. We're operating in Florida after all, which is a very car-centric transportation network, and so to get folks out of their cars and onto trains, we really have to deliver an experience that makes them want to come back. We're doing that in a lot of different ways, everything from ample bike storage and food cart service to touch-free bathrooms, power outlets, and USB ports at every seat. Seating that's designed so that every seat has a window, so there's no seats on our train that are next to a post. No matter where you sit, you've got a window. And ADA accessibility. We're actually the most ADA accessible railroad in the country. Our walkway aisles are all wheelchair accessible. You can wheelchair from one end of the train to the other, going through every single car, and we have level boarding at every station. Speaking of stations, these are great trains, but we connect great stations using those trains. So again, right now, Miami Central, Fort Lauderdale, and West Palm Beach stations are in operation. We're in the process of adding 2 inline stations, one at Aventura, Florida, which is on the northern part of Miami-Dade County between Miami and Fort Lauderdale, and another inline station at Boca Raton, which is between Fort Lauderdale and West Palm Beach. Both of these stations should be done at the end of the year. And of course, we're also extending to Orlando, and that station will open next year when our extension is complete. A couple pictures here of the stations. So again, to get people out of their cars and onto trains, it has to be a top-notch experience. That starts the moment you walk into the station, or in some cases before you even arrive at the station. This is the Miami Central station, the escalators up to the platforms. We do have ticket gates for our trains, so we can, for safety and security reasons, keep a close track of who's on the train in case an incident occurs or something. And we also have what I would call Security Light, a baggage scanner for folks' carry-on bags that checks for firearms and weapons and things like that to keep our customers on the train safe. You can also check luggage on our train if you prefer. Every station has a coffee shop, a bar, and a grab-and-go market, and every station has a main lounge as well as a premium lounge. As I was mentioning earlier, all of our stations also have transit-oriented development around them, so that you don't have a station just by itself, but really a more inviting area around the station. We want our stations to be not just stations, but also destinations. This again is Miami Central. Here you can see all 3 of those overbuilds, the office tower in the front, and then 2 apartment towers behind those that have been incredibly popular. I think, as you're probably aware, a lot of folks moving to Florida these days, we've been the beneficiary of that. Some of these other buildings around, especially this glass-fronted building here on the far left, we also built, we call that 3 Miami Central, and we own actually more property still around the station that in the future we will either develop or sell to other developers. And lastly, I want to say about our phase 1 operations, one thing we learned when we started operations in 2018 is how important first and last mile connectivity was. And so in 2021, we rolled out what we call Brightline Plus, which aims to fill that gap so that we're not taking people just from train station to train station, but really from their true origin to their true destination. And we achieve that in a variety of ways. When a person books a ticket in our app or online or even in the station, they can arrange that first or last mile ride. A premium customer can have a ride in a Tesla included to either pick them up at their origin, take them to their destination, or both. And any passenger is able to use the Sprinter vans, which are for shared rides to popular destinations like Miami Beach, the airport, things like that, as well as the circuit cars to take them to their final destination. These, by the way, for an economy ticket or a smart ticket, it's a flat price of $5 to add on to your trip. So typically, even if you're going just from Miami Station to the beach, you're talking a $20+ Uber ride that we can give you for $5 and get you that last mile. We also have e-bikes and scooters at all of our stations, and in West Palm Beach, we've rolled out Bright Bike now. We have 17 bike stations scattered around the West Palm Beach area for folks to easily get to and from the train station on these e-bikes. So that's our operation in phase 1. Again, operating today, hourly frequencies in both directions. You are more than welcome to come down and visit. I'd love to see you on board, and we'd be happy to host you anytime if you want to come check it out. But now I'm going to switch gears and talk a little bit about phase 2, which is our expansion to Orlando. Phase 2 is a $2.7 billion investment. It actually, that says 83 as of this week. I think we're at 84.4% complete. We've worked over 6 million man hours on the project so far, and we've got 1,000+ headcount on the job every day. Looking at the map, I like to use this high-speed rail lines map because it shows the train speeds and which parts of the corridor are shared. So starting at the north end at the final destination, Orlando International Airport, the first part of the project is split into 3 zones that we call zones 1, 2, and 3. Currently under construction. Together they're about 40 route miles, and this is new build with train speeds of up to 125 miles an hour, and that means it has no public grade crossings. We can't operate through public grade crossings at speeds above 110. Our main contractors for that work for Zone 1 is the vehicle maintenance facility where our trains will be maintained. The main contractors for that are Wharton Smith, who did the grading work, and then Hubbard the construction. I'm sorry, I said that backwards. Hubbard did the grading work, Wharton Smith did the vertical construction. For Zone 2, which is the track through the airport, those were built by Middlesex. And then Zone 3, which is the actual higher speed portion from the airport over to Cocoa, about 36, 37 miles, that was built by Granite. Here's a picture of the new train sets in the vehicle maintenance facility in Zone 1 in Orlando. And here's an aerial view. Just on those train sets, we've had 4 of the 5 new ones delivered. So for our phase 1 operation, we only need 4 train sets to operate Miami to West Palm. We started with 5. For the Orlando extension, we're doubling the fleet to be a total of 10 trains with an additional spare locomotive. So several of those new trains have already been delivered by Siemens to our facility here in Orlando. This is just on the south side of the Orlando airport. This photo is actually a little bit old because now all the track is complete. There in this picture, they just had the ballast laid out. But our trains, after they complete a run from the station, they'll come in from the station down here in the bottom left, come through the train wash every day, and then into the servicing facility where they get inspected, all the regular FRA inspections and our own internal inspections of both the train itself as well as the customer amenities on board. Servicing. This facility also has a fuel farm, sanding facility, wheel truer, and a locomotive repair track that has a crane capable of installing and removing the prime movers for the locomotives, the Cummins engines. So it's really everything you need to maintain a top-notch high-speed rail fleet. Here's a photo of the track through the airport station itself. This is just when construction was being completed. Now we're working on the decorative finishes for both the platform as well as the station area and lounge. So this will look a lot different if you come down and ride next year when we're done. Zone 2 is again the track through the airport. This is the track leaving. This is the train station here in the left in the background. Leaving coming to the north to head to the 528 expressway. Also in the background is a new Terminal C for the Orlando airport. This terminal is a brand new terminal that they just opened last month and has a direct connection to our train station. The airport, which is run by the Greater Orlando Aviation Authority, has been a fantastic partner that really has a vision for both intercity and local rail in Orlando. And so they actually built most of the train station. We only had to build the track part of it essentially. And they've had a vision for a rail connection to the rest of the state from their airport for a long time. And our agreement with them is basically allows us to build the track through their airport in exchange for us also building a wide enough guideway to accommodate commuter and light rail in the future. And so this grassy area you can actually see here is set, and where we're standing has the structures, the bridges and tunnels in place to add commuter and light rail in the future. So this is really going to become a multimodal hub for Central Florida once our train service opens and once those future local rail projects are constructed. Some more photos is the track. We have to weave in and out of a bunch of taxiways and things like that to get out to the 528 expressway. And this is where our trains will be able to speed up 225 miles an hour and travel those 40-ish miles over to Cocoa, Florida, where we join the Florida East Coast Railway. I'm sorry, over to Cocoa, where we join the Florida East Coast Railway. Just like I was saying earlier, again here, our track is built in the right-of-way of the 528 expressway. The line is primarily single track, just the easternmost piece is double tracked. Going from double to single track, we make that change using a number 32.75 turnout. This turnout is good for 125 miles an hour on the straight route and 80 miles an hour on the diverging route, minimizing the amount that our trains have to slow down when using the switch. It's got 5 switch machines, 3 for the points themselves and then 2 for the movable point frog. This is manufactured by Nortrack. All the ties are made in Cheyenne, and the track work itself is made in Alabama. Something else unique about Zone 3 is just some of these structures that we've had to build to cross over or under freeways. So this is arch tunnel where we will fly underneath the 528 freeway, and then in the background is a bridge over Interstate 95. It's quite a process to build some of these structures. On the far right you can see this compacted fill area where we actually built the shoe fly for the freeway. So the highway lanes had temporarily run here while we built this tunnel, and then this photo was taken just after we paved the new lanes over the tunnel. So now the highway is again in its final configuration, and it's all ready for us to build track underneath. So that's zones 1, 2, and 3. The rest of the presentation I'm going to focus on what I'm working on mainly, which is zone 4. That's the biggest piece of the phase 2 expansion. It's 129 route miles, and this is the project double tracking the existing Florida East Coast Railway corridor between West Palm Beach and Cocoa. It's 156 grade crossings, which I'll talk more about, and we'll be able to operate at maximum speeds of 110 miles an hour on this corridor. And again, we are double tracking essentially the entire thing. There's only a few thousand feet over a very long bridge in Stuart, Florida that we can't double track. So there'll be one short piece of single track, and the entire rest of the line from Cocoa to Miami will be double track when we're done, and in some cases triple track. This work is being done primarily by HSR Constructors. That's a joint venture of Herzog, Stacy and Whitbeck, and Railworks. Those are 3 major track construction contractors in the U.S. and they're building that piece as well as doing the track work for Granite from Cocoa to Orlando. So jumping into Zone 4, I want to cover a couple different aspects. First the track work, then we'll talk a little bit about grade crossings and a little bit about bridges. Again, this is what I work on day to day, so I'm most excited to talk about. Also, I know there's some students in here who are taking the Shared Rail Corridor class, so I figured it's timely to dive into a little bit more of the detail on that. I did, though, speak at the TIE Symposium in April or May here, and that presentation is on YouTube, so I don't want to duplicate what some in the room have already heard. So if you're interested in learning more about the quantity of ballast and ties and fastenings and things like that that we're using for the project, I would encourage you to go to the Railtech YouTube and watch that video, because I'm not going to cover it again here. Instead, I want to talk more about some of the unique things that we're doing because we're working on a shared rail corridor that we wouldn't be doing otherwise for this project. So just to give you the high level of what's going on, we're dealing with one existing Florida East Coast Railway track. Again, it's a single track route with passing sidings. To get from Class 4, where they currently operate, to Class 6, which is what we need for 110 miles an hour, we have to rehab that track. So we'll do tie replacement, spot tie replacement, installing new ties, replace rail where we need to, replace fastenings where we need to, and then build that new second track, which is what you see there on the left. That's got all new ties, 136 RE rail, and new ballast. The construction process for the track is pretty straightforward. I wish it was all this easy. Basically, we compact the subgrade, add the subballast, compact that. We lay out ties, usually with the tie dragon. And then you can see in the far left of this left photo, there's some CWR rail laid out that's been dropped by the rail train in advance. The next step here is for a speed swing to come, thread that rail over, and we'll clip the new rail to the ties so that you have skeleton track. Once the track is skeletonized, next step is to bring the work train in with ballast, place ballast on the skeleton track, and then surface it up to its final elevation or configuration. And I don't have a picture, but actually the most important step is the de-stressing, which sets the rail at the right neutral temperature once you have the track at its final alignment. Pulled a couple screenshots from the track chart. I know this is a lot, but I want to point to one specific area. So this orange line at the top is the existing condition of the Florida East Coast track before we started construction. You can see it's all single track. Right here is a very typical location where we have a 2-degree curve. 2 degrees of curvature is too much for us to operate at 110, so we need to reduce the curvature. And you can see circled there below, we need to make the curve 45-minute curve, so that's about 3/4 of a degree. And this, where I've circled here, you can see there's 2 lines, the black, which is the existing track, and then the green, which is the new track. Here we've come and built the new track to design to the new curvature, so that's about, again, 3/4 of a degree, and the existing track is still at a 2-degree curve. A few weeks later, after we shift the existing track, now you can see the existing track matches the new track, and they're both at the new curvature. This is a location down in St. Lucie County where we're actually going to start testing trains at 110 on Monday. Similar thing here, we're working with the property constraints that we have from the existing Florida East Coast Railway. Everything's being done on their property, so in some cases to get those speeds, we're shifting essentially all the way to the edge of the right-of-way. Here you're seeing the 2 new tracks that are coming basically as close as possible to the existing right-of-way line. That bold black line is a wall, and here's similar thing. You can see what that looks like when it's done. The ballast off to the left is where the existing single track used to run, and then the 2 new tracks right up against that wall have much more gradual curvature so we can get the train speeds. Another thing that we're doing a lot of is cut and throws. This is where you build a new track on one side up to a curve, and then the new track is on the other side of the track, coming from the other side of the curve. And what we're going to do here is cut the track just about right underneath that locomotive, and then tie the track that we're standing on into this new track on the right, tie the track the rest of the train is on onto that new track on the left. That results in 2 mainline tracks that both have a lower degree of curvature. And that train, by the way, is one of our 4 work trains that we use to distribute material to the project all up and down the corridor. Another thing that we have to do a lot of is swap overs. So again, all the bridges on the line, which I'll talk more about bridges in a minute, are existing single track bridges. We need double track. So what we typically do is we'll build half of the new bridge right next to the existing bridge. And then what we'll do, we'll take a day where we can get an outage and we'll tie the existing main line, throw it over and cut it into the new bridge so that freight traffic starts to run on the new bridge. And that gives us a chance to come in, tear out the old bridge and rebuild it so that the end product is a brand new double track bridge. So what you're seeing in this photo on the right is mid-process of that cut and throw where we've cut the old existing track. This is the existing track. Cut it right here. We've slid it over. We've tied it into the new track. Now we're going to bring in some ballast, surface it up so that we can start running freight trains for the next couple months temporarily on that new track and over that new bridge. Something else that's unique about shared rail corridors that we're doing a lot is adding tons of crossovers. I think we have 42 or 44 total crossover turnouts. These are all number 24s that have a diverging speed of 60 miles an hour. So freight trains can actually maintain full speed even when they cross over between mains. And our trains will have to slow down from 110 obviously, but 60 is still pretty good. And we're placing them at frequent intervals. So when the project started here, you can see they're at about 4 mile spacing. Typically they're at 6 or 7 mile spacing. When the project started, there was quite a bit of RTC modeling work that went on, us and FEC together in the room trying to get the best configuration possible for the infrastructure so that we could operate both freight and passenger efficiently over the line. Here's a photo of one of those number 24s being put into the existing track. To do this, what we have to do is wait till we can get an 8-hour window from the freight traffic. We will cut out the track, the existing track where the turnout's going to go, and then have the turnout pre-assembled off to the slide it in on these slider rails, and tie it all back in so that we can let freight traffic through later that evening. Here's what one of those crossovers looks like when it's done. This is CP Rio in Jensen Beach. One thing you'll find is frequently a problem on shared rail corridors in North America, and we're no exception, is heavy point frogs. So freight railroads tend to prefer heavy point frogs because they have a longer wear life. They call it a heavy point frog just because the frog point here is wider. That's great. FEC is no exception. Again, you get a longer, better value out of your frog when you have that heavy point frog. The problem is because of that wider frog point, it's harder to meet the FRA required tolerance for guard check gauge, which is 54.5 inches. And so as a result, we've been giving our crossover turnouts a lot of TLC. You can see some shims the far left on the tie plate as well as shims in the guardrail. There's a lot of fine tuning going on to make sure the frog is in the perfect spot, getting the guard check gauge within tolerance while also keeping the track gauge and the guard face gauge in the right place. And again, this is a problem for shared rail corridors all across the country. One more thing I'm going to point out in terms of track work from the track chart is we have to be able to accommodate the local traffic. So FEC has a lot of online customers that they serve, and we need to make sure that those local train operations can continue reliably and that our operations are not going to interfere with them, that their operations are not going to interfere with us, and that means adding infrastructure. And so in this example here, you can see this is the Bonaventure switching lead here in Bonaventure, Florida. What we're doing is we'll add the new second main, but we'll also extend the switching lead so that it serves this one last customer that's not on the switching lead, and also gives the local train more space to work and sort cars without fouling the main lines so that mainline traffic can continue to operate even while the local train works serving those customers. And here's a photo of that Bonaventure switching lead. So again, you can see on the far right the brand new track we are just in the process of building here. This is the existing main line, and then what we've done here with these joints is we've cut out this turnout which used to run right from this track into this industry. And we've slid the turnout over, and we're going to put it in this new industry track that we're building here. The wood ties are laid out for that new industrial lead. So that customer now will be served off of the switching lead instead of off the main line, keeping those local trains off the main lines and letting our higher speed passenger trains continue to operate. So that's track work. Crossings I'll cover really quick too. I did give an RTNS seminar about grade crossings recently, so I'm not going to touch in huge detail on these because you can always go back and watch that. But I thought I'd just touch on the construction process really quick. It starts way before we ever get in the field, doing a lot of hand-to-hand combat. Hand-in-hand collaboration with all the communities on the line. 20 plus cities on our route, 6 counties and 2 FDOT districts. We need to coordinate every design, every aspect of every design with every single one of them, which is a huge process that we've been working on for years. We just finally received the last construction permit for the last crossing 2 weeks ago. So now they're all permitted, which is amazing. And that's great too because we're about 85% done on crossings. So we're getting down to the last 20 or 30 crossings. All the other ones are done. Doing all this crossing work requires a ton of media communications, communicating crossing closures, detour information, and of course the safety improvements we're putting in. Some of these larger crossings, the closures can last 10 to 14 days because there's so much work to do. And so it's a challenge for the public, and we need to be able to communicate exactly what's going on to them as well as the detour routes when we reopen, so on and so forth. Typically when we're doing a crossing, this is what you start with. This is a single existing FEC freight rail track. What we do, we come in, we close the crossing, tear out the roadway. In this case, we're not touching the existing main line, so you can see the existing main line just stays in place. Freight trains can continue to operate. Dig down, compact the subgrade, add the subballast, compact that. We have to test it all. That's the nuclear density testing gauge. Bring in the new track panel, flood it with ballast and surface it up, get it aligned, and then you're ready to put the crossing panels on. That's an easy one. The hard ones are where we have to adjust the existing geometry of the mainline track through the crossing. Often we're doing this to, again, achieve that curvature that's more favorable for high-speed operations. Or in the case of this picture, this is another location where we're going to add the second main to the right and then another switching lead after that. So we need to shift the existing main over to the east side of the right-of-way. The crossing work typically precedes the track work. It's kind of a longer lead item. So what happened here is we have to shift the track over in the crossing while we're redoing the crossing and then put a temporary S-curve alignment in the existing main line until we can come back later and shift the rest of that mainline track. We always build the temporary alignments to be good for the maximum freight speed, which is 60 miles an hour. Sometimes we also have to replace the existing mainline track panel in the crossings. Some of these crossings where you have a lot of truck traffic, the crossing doesn't last that long, maybe 7 to 10 years. And so some are at the end of their life when we show up and we have to come tear the existing track out during an outage in the main line, put in a new track panel, flood it with ballast, surface it up, and get it in service for freight trains again after just 4 or 6 hour outage window. Once the panels are on, we do the asphalt paving, the striping, and there's usually a lot of associated curb and gutter work, drainage structures, as well as sidewalks and things like that that we have to place. We're also placing these dynamic envelopes at every crossing. This is something FDOT asked us to do. These are designed to make drivers more aware of where the dynamic envelope of the train is to try and deter drivers from stopping on the tracks. Also, because we're operating at speeds up to 110, there's additional safety improvements that are required at a lot of crossings. And so nearly every crossing where we operate over 79 miles an hour is going to get either exit gates, so quad gates, or raised medians, or both to deter drivers from driving around the gates when they're activated. A lot of signal work at the crossings too, Here you can see in this right picture, we're relocating that cantilever arm and the gate itself to the new foundations in the foreground. It's right here. so that we can move them out of here and make space for that new second track. A lot of crossings were replacing the entrance gates with new gates, also adding the exit gates. Many of them were also placing new signal bungalows, new battery boxes. These are batteries with backup power for the crossing, as well as generator cages. With the hurricane, of course, recently, that's a pretty common thing now to add these generator cages where you can put a generator to power the crossing if you're out without a commercial power for longer periods of time. 2 or 3 days, the batteries aren't going to last, and generators get stolen very easily in a hurricane, unfortunately, so you have to put them in these cages. Last thing to do is then when you cut that new second track into service, you have to time all the crossings again since you've rebuilt them. And so what we typically do is we have flaggers at all the crossings, and we'll walk down the crossings with the flaggers long in advance of the train's arrival just to make sure no vehicle traffic is moving. And then we can test and time the crossings to make sure the gates and lights and everything meet the federal and local requirements. Plenty of challenges come with building these crossings. There's at least 3 that go through the middle of a roundabout, believe it or not. And so that's a lot of fun, both because, keep in mind, we have to modify the whole roundabout to make space for the second track. We have to repave the entire roundabout, restripe the entire roundabout. But worse than that is, this roundabout's here for a reason. Like, if we could move it, we would. But it's a convergence point for a lot of main roads, and so the detours are just miserable. And you end up getting pretty much massacred in the local media, closing this for 10 days. On the right, complex geometries. So downtown Melbourne, where we've got about 7 crossings in the space of 3,000 feet, takes a really good surveyor to get those panels lined up right. You really got to know what you're doing, because you don't want to put all those in place and then find out later that they don't line up and the track's not going to be straight. That's no fun. Another problem we have with, challenge that we have with crossings is access. So the track follows pretty close to the Indian River, the Intercoastal Waterway. A lot of places you could only get to the barrier island by crossing the track. So what we have to do in those cases is either rebuild half of the crossing at a time so that vehicles and emergency services can operate over the other half, or in the case of smaller roads, build a temporary crossing like you see at the bottom here, where for the whole crossing closure, even if it's 10 or 14 days, have flaggers out flagging traffic, stopping traffic for trains while we rebuild the main crossing. Lots of fun. That's what one of those temporary crossings looks like. Another issue that we have with the crossings a lot is saturation. Again, this is downtown Melbourne, all these crossings in a row. Each crossing has a physical approach circuit. Each of those approach circuits is associated with a certain AC frequency. So we have AC crossing circuits and DC track signaling system. There's only so many AC frequencies you can use for the crossing. In a place like this, there's so many crossings that are saturated, so it requires some really specialized signal design to make all of those approach circuits work properly. We have to have preemption timing for all of the traffic lights on adjacent roadways to clear and queued traffic off of the crossings, and there's a ton of crossings with adjacent roadways. So that's a whole separate effort, is preemption timing. Last thing I want to touch on today before I close is structures. So between West Palm and Cocoa, there are a total of 30-some bridges. It's Florida, so there's a ton of waterways. And we are building a total of 28 new structures. So a lot of these bridges we're tearing down and replacing. For the shorter, smaller waterways, we're typically using standard concrete box beams. These are for spans 35 feet and less. These are really quick and easy to install. A lot of these bridges we can build in 2 months or less. Some of them we've built in 1 month or less. I mean, they're really quick. At the other end of the spectrum, for those long spans, we need steel deck plate girder bridges. Our longest one on the project has a span of 163 feet, and that's crossing over Interstate 95. That's actually on Zone 3, not on Zone 4. And there's places, too, where we're paralleling the highway where we need these straddle bends for the bridges to accommodate the geometry of entry and exit ramps onto the highway. We have a few steel through-plate girder bridges. These we're using where we need the extra overhead clearance for roadway or waterway traffic. Great example of that is actually in Melbourne at the Crane Creek Bridge. This is a bridge that crosses both the roadway and the waterway and has a history of bridge strikes on both. You can see how little clearance there is underneath the roadway here. This is the old existing FEC bridge, which during construction actually did get struck by a concrete truck unassociated with the project, and you can see what the main line looked like after that happened. Fortunately, the FEC engineers that built this railroad 100 plus years ago were smart enough to build most of the bridges on the corridor to all have the same span length, so we could grab an old span from a different bridge and put it in temporarily until the new bridge was done here. Here's what that new bridge looks like. This is the first half is done. Our train is doing qualification runs on the old bridge. But you can see these two through plate spans here over the waterway and then here over the road so that we can get that higher clearance for boats and vehicles. The rest of them are deck plate girders. We've also got concrete I-beams on a lot of the station tracks. These are standard I-beams, very common in Florida. This is like every highway bridge in Florida. The construction contractors know how to build them. They know how to build them quick, so that's great. They do require separate concrete decks, and we're mostly using these in our station tracks. We are doing something quite a bit new with concrete I-beams as well, though, and that is using ultra-high performance concrete for the closure pour on some of our bridges, which means that no deck is required. So I'll show you a photo in a minute, but basically these are the beams, and then we pour that ultra-high performance concrete in between the beams to connect them together, and that just forms the deck, and then we're putting ballast basically right on top of the beam. So that way we don't have to pour a separate deck. It reduces the dead load on the bridge and makes the bridge quite a bit more economical as well. FEC was a little suspicious of it, so they made us go back and put these steel diaphragms to connect the beams together. So all of our bridges that use this technology on the shared rail corridor have those diaphragms, even though it's really kind of a belt and suspenders measure. Our bridges on Zone 3 that use this do not have those because we control our own destiny on our passenger-only trackage. Here you can see a photo of that closure pour going on. This is the ultra-high performance concrete. It's got a compressive strength between 20 and 24,000 psi as compared to 3 to 5,000 for more typical concrete. So it's amazingly strong. And here is one that the closure pour has just been completed, and this is basically ready for the waterproofing and then the ballast. And finally, on structures, we need to touch on drawbridges. So this is Florida. There's a lot of waterways, a lot of boat traffic. Nobody's going to give up their waterways for us, and we need to keep these drawbridges in service. So we've got 3 drawbridges on the shared corridor, one that was in phase 1 in Fort Lauderdale, downtown Fort Lauderdale, that we rehabbed all the electrical and mechanical components for phase 1. Phase 2, we've got 2 additional bridges on the shared rail corridor. One is Stewart, where we're also just rehabbing the electrical and mechanical for the drawbridge, as well as installing a new tie deck. And that's that one piece of single track that's going to be left when we're done. And then the last one is the Jupiter drawbridge at the Loxahatchee River, and that bridge we're completely rebuilding. Got some pictures of it here. We have to replace the spans 1 or 2 at a time. They sit on new bents that we installed underneath the live track, which was quite a process. When we install those new spans, we have to tear out the top piece of the existing spans all in one go. Doing this typically with about a 12-hour track outage window. So a lot of planning goes into that. When we replaced the drawbridge itself, what we had to do first was take out the old drawbridge in one 24-hour window and then put in this yellow jump span, which allows train traffic to flow, but it's removable, so we can take it out twice a day to let boat traffic through. And we did that for about a month until we could install the new drawbridge. What you're seeing here on the right is the trunnion for the new drawbridge. So this is the counterweight box. Let's see if I have a picture of it. Yeah, this is the old counterweight box here. This is the new counterweight box laying on its side on the ground, and this is the trunnion that the bridge actually rotates on. So we just pulled it with a crane out of a liquid nitrogen cooler to get it down to a low enough temperature that it would contract so that we could lower it into the counterweight box, and then as it heats up, it'll expand, fill out the counterweight box so that it can't be removed. So that's how you get the trunnion in the counterweight box. pretty cool, I thought. Here's the new drawbridge itself being lowered into place during another track outage window we got. And then it gets connected up to all the electrical and mechanical components and the counterweights themselves. Here's the first train going over the new drawbridge. Again, this was single. It had originally been in the 30s when it was built, a double track. It got changed to single track in the 70s. Now we're making it double track again with all new bridge. So you can see this is the first train operating over one of the new tracks, and we'll install the second new track here shortly. And then a few hours later, the first boat going underneath once we got it operational. And then, as I mentioned, any existing decks that we're leaving, usually we're only leaving them if they're newer deck plate girder bridges with wood tie decks. We replace the wood tie decks just to get everything up to the best possible state of good repair before we start operations. I'm not going to talk about signal cutovers today. We're still in the process of that. Maybe that's a future presentation, I don't know, but a lot of work going on the signal side to put the new track actually into service, get the PTC up and going, and then the high-speed testing, which, as I mentioned, we're starting on Monday. So stay tuned in the future for that. But I just wanted to close by talking about the future of Brightline. You know, I told you about phase 1, told you about phase 2 that we're almost done with. You know, so what's next, right? The most immediate answer is Tampa. So once we're done getting to Orlando, the next thing we're going to start focusing on is going to Tampa. Our alignment from the airport, which is on the east side of Orlando, over to the theme parks and the convention center, which is on the west side, is going to be a shared corridor with Sunrail, which is a local commuter rail service. So they'll have frequent service on the line in addition to us. And then from there, we'll leave the South I-Drive station, which is right by Disney World, and run in the median of Interstate 4 all the way to Tampa. And that, just like the rest of our operation, is going to be an hourly service connecting those two cities. Beyond Tampa, the other thing that we're really excited to start construction on soon, I mentioned it at the beginning, is Brightline West, connecting Las Vegas to Southern California. This is going to be a true high-speed line with train speeds up to 200 miles an hour, fully electric train sets, zero emissions, greatly reducing the travel time between Los Angeles and Las Vegas. And with that, I'd like to say thank you, appreciate you all coming and listening, and I'd be glad to take any questions if we have time left.
Let me start by thanking you, Tom, and knowing TC is somewhere smiling very broadly right now. This is exactly the sort of thing I think he would have loved to see his students working on. It's a fantastic accomplishment. So really
Appreciate that, thank you.
Can you flip on the lights there? I think it's the last switch. Oh yeah, I'm sorry, the other, no.
Oh, I'm sorry. Let's try that. How's that?
That's one more.
It's the, yeah.
All right, thank
There
you.
we go.
We have time for questions, so we'll open it up.
Yeah, so that spoke a little long, but.
So you mentioned in Zone 4 you had 156 grade crossings. Was there any effort in your combat/collaboration that you to close any crossings to kind of try and reduce the liability?
A little bit. Communities that are willing to look at crossing closures, you know, we would definitely partner with them. There was one that has been grade separated during the course of the project, but it tends to be a challenge, and well, there's a couple factors at play. First of all, we're not the operating railroad, right? So that's more of an FEC thing with the communities than it is us, because we just operate over their property and line. But also, you know, this being South Florida, these are also not like farm crossings or local private crossings that are relatively easier to close. A lot of these are busy traffic crossings. The other thing to keep in mind too is just the way that Florida developed. Dixie Highway and US 1 were built right parallel to the tracks. So, you know, on every corner right by the tracks, there's businesses. You can't just easily raise the road in most places because you would cut off so many businesses. So it's incredibly complex. It's definitely something that we're still thinking about. We want to look more, especially in South Florida, at locations where we can still grade separate and work with FDOT and local partners to move in that direction. But for this project, it wasn't something that was feasible on a large scale, especially with the timeline that we were building. But definitely something we're interested in.
Other questions? I know the SRC class members have questions, and we have many more questions for them that will cover this afternoon, so.
Well, first of all, great presentation. I do have one question, and that is, how has been the response been, the reception from local residents and from the community in general? Also, is there any like significant opposition to building the project, whether it's from local residents or politicians, and if so, how to deal with this?
Sure. So there was, it depends on where you go. So we're very popular in Miami, Orlando, West Palm Beach. Everybody's excited. You go to church or you go in the barber shop and they're like, oh, you work for Brightline? I can't wait to ride. You go in some of the rural areas between the two where we're not building a station, and the story is the opposite, and you're not so popular if you work for Brightline. There was a couple times where I was going to try and get like easements for, we needed a power line to a new intermediate signal, for example, and I was trying to get an easement from a landowner who told me Brightline was going to destroy his town and he never wanted to do business with us and I needed to leave. And I'm like, okay. So, it just depends on where you're at. Fortunately, most of the larger scale community opposition that we saw, we were able to find, middle ground compromise with, they had safety concerns, for example, so we were able to work with them to install additional safety improvements to allay those concerns. Other than that, I would say both, within the governments of most of the communities in the state, they've been great to work with, and most of the communities we operate in have also been great to work with. Some of the more forward-thinking communities, Brevard County and specifically Cocoa is one that has actually made a great effort to work well with us because they want us to consider adding a station in their community in the future, and so they've been great to work with too. So it just kind of depends, but it's a great question. Yeah, I can repeat it.
Why is there not a COCO station as a part of the current plan? Just ridership projections are not there yet, or it seems like a logical place getting people.
Sure. So the question is, why is there not a COCO station as part of the plans? And I think the main answer to that is, so far, all of our focus has just been on getting to Orlando. It's hard enough just to do that, right? That doesn't mean we don't want to come back later and add in inline stations at certain places, but we are an intercity rail service at heart. We don't want to become a commuter rail service, if that makes sense. And so our focus till now has been getting these farther city pairs connected, and then we can come back later and look at if it makes sense to add inline stations where either all trains or maybe just some trains stop. So it's definitely on the table, but not something that we've focused on yet.
I'll ask one question. I've got a lot, but we'll talk later. Have you had any problems with loss of shunt in terms of activating the grade crossing warning systems?
No, fortunately not. Where we operate passenger only, we have had that issue. Where we operate passenger only, really there's no grade crossings though, but for the signal system, when we build the track there, we have to then come with a brush truck that scrubs off the top of the rails essentially to get the mill scale off so that we do get the shunt, and after that we've never had any issues. On the shared rail corridor, as soon as we put a piece of track into service, freight trains are operating, so it's not an issue there because they get all that mill scale off within a couple train passes, and then you're good to go.
Yeah, but as you probably know, we do have a problem here on the line, the CN line to Chicago, and that's got plenty of freight traffic and a handful of relatively light, short passenger trains, and
Right.
we continue to have a problem, so I'm curious.
Right. No, I mean, I can't say exactly why we may have a problem with that here and not on Brightline. I mean, I guess we don't have the fall weather and the leaves and things like that, maybe, but I doubt that's the reason. But no, it's as soon as the track has been in service for a while and there's been enough train traffic to get the mill scale off, we haven't seen the issue again.
We have one more
Yes, sir.
question here, and we have a lot of questions pouring in from online.
What are the challenges on the train control side of the shared corridor to accommodate the FEC trains, the ETC system, and the PTC on that?
So we basically have just adopted what FEC already uses. So we use their ATC automatic train control system. We did have some challenges early on. The system we initially, so before we arrived, FEC wasn't required to have PTC, just the way the regulation is written. They didn't qualify as needing to have PTC. Because of our revenue passenger rail operations, PTC became required on the corridor. The first PTC system we tried had quite a few issues, so we had to uninstall it and install a different PTC system, which we've now done successfully, and it's working quite well. So that was definitely a lesson learned. But I mean, other than that, we've done well just doing exactly what FEC does, partly because we know it works and partly it's because that's what they want us to do. And so even on the passenger only lines going over to Orlando, we'll still use ATC and we'll still use PTC, and the dispatcher for all of the traffic is still the same person for all of the freight and passenger traffic, both on the shared use lines as well as on the passenger only lines and the freight only lines. So.
Okay, well, again, we've got lots of questions coming in from people online as well, so I'll start with one of them. We may not get to all of them. How do you handle underbalance in a curve with super elevation for freight trains on curves that you've improved, and underbalance would result in loaded freight car leaning heavily on the handrail and more wear and tear?
So we've agreed with FEC on a maximum super elevation of 5 inches in all the curves on the shared rail corridor. And that's kind of the limit that they want to stick with to avoid that problem. FRA regulations allow you to go up to 7, not that that's a good idea, but we can. On our passenger only line over to Orlando, that 40 miles in zone 3, we have super elevation up to 6 inches because it's passenger only and there's no freight to accommodate. But again, on the shared rail corridor, it's up to 5 inches maximum.
What will your crossing activation times be on those sections of track where train speed is about 79 miles per hour?
They'll all comply with the federal laws. Typically, we run about 30 seconds, and it'll be the same thing no matter the train speed.
And you may have already addressed this, but I'm going to ask it just in case. What is the train control system between Orlando and Cocoa?
It's the same. So it's ATC with CTC, so centralized traffic control, and then PTC overlaid. So the centralized traffic control, the dispatcher is based actually in Jacksonville, and our dispatchers work for a company that's a 50-50 owned subsidiary of Brightline and FEC. So FEC owns half, Brightline owns half. The dispatchers work for that subsidiary company, so they, don't have an incentive to prioritize one or the other set of train traffic.
What are you doing to minimize the chance of accidents involving freight trains?
Well, PTC is the main one.
Well, I guess other things, say an adjacent track around, let's say.
I'm not sure that we have anything specific in place beyond what's typically required or what you would find, for example, on the Illinois high-speed rail main line or the Capitol Corridor or the Cascades. We do have wider track centers, so we're widening the track centers. Typically before they were 13 feet, we're widening them to 14 feet. But I don't believe there's anything in addition to that. But, I mean, there's not a major issue with derailments on the FEC corridor as it is. We're making all the track brand new. Right. I would think and hope that's not going to be a major issue.
All right, here's another question. question. Are the turnout specs for the Orlando segment optimized to the characteristics of passenger equipment, or do they follow ARIMA standard plans?
They do follow ARIMA standard plans. We actually, because we ordered all of the turnouts in bulk, it's the exact same thing that we have for Zone 4. We just ordered, 100-something turnouts as part of a bulk order with Nortrack, and it's the same specs for the entire line, with the exception of that number 32 because it's unique.
Okay, different line of question. What special features are you incorporating to deal with severe weather, hurricanes, that sort of thing?
Couple different things. So mainly just great drainage designs, right? We're redoing the drainage in a lot of areas, adding additional culverts, raising the track, things like that. Some of the newer crossing gate systems or warning systems at the crossings are maybe a little bit more resilient. They're tougher. They're the newer models of gate mechanism and things like that that stand up better to hurricanes, but a variety of different things.
On your shared trackage, how many freight trains per day are operating when you're operating lots of passenger trains?
Depends on the day, typically about 14.
14
FEC,
freight trains.
yeah, FEC has several like through freights that operate between Jacksonville and Miami. Fortunately, most of them run overnight. That's the demand that they get from their customers is their intermodal customers especially want to drop freight off in the afternoon, have it move overnight and be ready for them first thing in the morning in Miami or Jacksonville. So most of their trains run overnight, which helps, but there's quite a bit of local traffic during the day too.
So related to this, that's partly why I asked the question. A two-track railroad with a high-speed differential such as you have will be challenging to operate given typical U.S. train dispatching practice. Is the infrastructure designed to a timetable, and do you anticipate a special level of training and education for your dispatchers?
Yeah, definitely. So it is designed, well, I don't know if you would say it's designed to a timetable because it's all double tracked, but both the freight and passenger trains run according to a timetable. So FEC's trains run on a schedule. It's not as tight of a schedule as the passenger trains, but they do come at the same time every day, which is very helpful, by the way, when you're working in construction to know how long your windows are going to be long in advance because you know the 206 comes at 3:30. Yes, so for our operation, both the freight and the passenger trains are scheduled, and we've built more than enough infrastructure to accommodate that with the double track and the number of crossovers we have. And in fact, we've even done RTC modeling to see with this infrastructure how long are our work windows going to be on certain segments once all the double tracking is done. So for example, we wanted to know, in this segment from crossover B to crossover C, if I take one track, what's the longest window I can get without delaying the freight and passenger trains running only on that other single track, and often in cases it's 9, 10, 11 hours. So there's more than enough capacity the way we've set up the infrastructure for future expansion. And that's one thing we've focused on, setting up the infrastructure. So the infrastructure is not designed for the 14 trains a day and the 34 Brightline trains a day. It's designed to accommodate future expansion for both. So there's plenty of capacity left.
What's your rail grinding plan, and what's the initial type of profile?
So on the shared corridor, FEC does all of the track maintenance. So the grinding will be in accordance with their current plans. We have the standard ARIMA 136 rail. Our trains use, I believe it's apt to 340 profile. On the passenger-only segment, the Zone 3 over from Cocoa to Orlando, we are going to have to probably grind that before we start operation, both for the shunting issue and also to get the profiles tweaked perfectly. Because the tonnage on the passenger-only line is so light, I don't foresee having to do really frequently grinding. We're only talking a couple MGT a year. So it's not a heavy haul freight railroad that's got 30, 40, 50 MGT a year.
We'll just ask a few more questions. We've been going for long. Will freight trains be held out of stations during passenger train loading?
No. In fact, the stations that are in line on the shared rail corridor have 2 platform tracks and then the third runaround track. So you can actually run freight trains around passenger trains while a train is loading in the station. So there should not be a scenario where a freight train is delayed because it's waiting for a passenger train to load at a station, even if that passenger train is running late.
How often do you open the drawbridges, or are some of them open until a train comes?
Yeah, they are. The default position is open, just because the boat traffic is so heavy. And that's been, to the question earlier, one of the challenges working with communities. The boating community is really concerned because the bridges are going to spend quite a bit more time down. But you have to keep in mind that our trains pass really quickly. There are only 6 cars total, right? So the amount of time, extra time that the bridge is going to spend down is not a ton in spite of the extra traffic. And we're double tracking those bridges. So in some cases we're passing trains near or on the bridge, and that also helps with keeping the bridges up as much as possible.
How does the passenger traffic levels that you've achieved compare to your expectations?
We have never been more excited about the ridership we're getting. So we're already at ridership levels 30 to 40% above pre-COVID, which, as most of you know who follow the passenger rail industry, a lot of transit properties are still today seeing ridership levels below what they saw pre-COVID. So it's exciting to be above pre-COVID levels. We think we're on track to hit about 1.5 million riders this year, which may not sound like a ton, but keep in mind that's more than all but like 4 Amtrak lines, and that's only on one 67-mile route.
Okay, I think we'll just take one more question here, which is, what is the longest FEC train length and what's their maximum authorized speed?
I don't know the exact train length. I would say probably 8,000 to 10,000 feet. And the maximum speed for the freight trains everywhere is 60 miles an hour. So again, because we're all double track, we don't have to worry about siding lengths or siding extensions or anything like that because we're all double track.
I think we'll wrap it up, and again, I want to thank you for an outstanding seminar.
Appreciate that.
Really, really appreciate this, and
Thank you.